Okay, so welcome to the part 2 about Ivy Bridge motherboards and overclocking. So on this one we will be testing out my brand new 3770K that I recently received after sorting out all of the issues I had with this particular chip in the first place. So the overall rig is exactly the same as in my previous video, so Asus Maximus 5 Extreme motherboard with 1604 BIOS from very late 2012. The 3218C batch 3770K that I showed you briefly in the previous video, and this particular chip could very well be one of the best, if not the best, Ivy Bridge 3770K CPUs that ever existed. 3218C batch was considered one of the best batches to look for back in those days, like 3218C, 3229, 3230. Some of those fairly early Costa Rica batches anyways. The CPU has been delidded. There's Thermal Grizzly Conductonaut between the die and the IHS, and Kingpin cooling KPX, the blue thermal paste between the IHS and the water block. So yes, I am still using the original IHS, so I am not running direct die cooling. Memory is the same kit I've been using quite a lot in my recent videos, so 2x4 GB G-Skill Trident X 2600 CAS10 memories, which refer to 1600 by default after clearing the motherboard's CMOS. But yeah, so let's just cut to the chase straight away so we don't have to waste too much time on the BIOS welcome screen. So we will just run the tests in the same Server 2012 operating system where we ran those 4790K tests as well. So let's just press F1 to run the setup. So let's try to aim for 5 GHz straight away, as this CPU should be absolutely awesome based on the information I got from the previous owner. So yeah. So let's just go through the settings quickly. So AI overclock tuner, we will set this to manual. 100 base clock, ratio synchronizing control, we want to keep this enabled because we want to run all core overclock at this point. So we will load 50. And internal PLL overvoltage, you have to enable this. Memory frequency, we will load 2600, which is the standard frequency in the XMP profile of this kit. We will enable extreme tweaking and SPI booster, although these shouldn't really matter for daily use anyways. Then DRAM timing control, I will just load the main timings, 10, 12, 12, 31, but I will use command rate 1 instead of 2. All of the subtimings can be left at auto. So Digi Plus power control. One thing I noted with this particular motherboard is that ultra high is the closest setting to the set VCore value. With the ultra high load line calibration setting, there's usually a 10 millivolt drop under load. I mean between the idle value and under load. So if you set 1.28 volts in the BIOS, with ultra high load line calibration, the VCore should drop to 1.27 under load. Extreme is the option you should use on LN2. That one seems to overshoot like 10 to 15 millivolts on idle and 25 to 30 plus millivolts under load. So extreme is very good for any kind of like not stress testing, but benchmarking purpose, no matter if it's like water cooling or SS or dry ice or LN2. So let's just try with ultra high first. Voltage frequency, as the maximum is only 500 kilohertz, we can easily max this out. 500 kilohertz is nothing. Power phase control, you want to use either extreme or manual adjustment at ultra fast. I will leave it at extreme. For testing purposes, we want to max out the VRM completely. So extreme. This current capability should be at 140%, 150%, or even disabled. On LN2 you should set disabled. So we can put these manual 500, extreme 1.65x. So those are those should be it. So VCore, manual, let's try with 1.28, 1.65, 1.2 and 1.2, and PLL 1.7, and disable spread spectrum. CPU I will disable the execute disable bit, and yeah, these should be it. So let's load these settings and let's see how this will actually run in the operating system. 5 GHz with only 1.26 volts or 1.28 volts sounds a bit crazy, right? So let's see how this will run. F10, save and exit. So Windows Server 2012 is loading right now. And yes, the operating system has been heavily recycled, so it's not the most optimal one score wise. So CPU Z plus core temp, so 5 GHz on all of the 4 cores, 1.28 volts. This temperature cannot be right, so the first core is for sure bugging, because the rest of the 3 cores are around there where they should be. So let's see. Let's open a Benchmate, Cinebench R15, and let's look at the values. So 1.28 volts, ultra high, it should drop to like 1.27 under load. So look at the core voltage value. So it dropped a bit, like 8 millivolts, from 1.288 down to 1.28. But look at these temperatures, 40, 47, 47, 45. So as I already said, liquid metal between the die and the IHS, KPX, the best conventional thermal paste between the IHS and the water block, and we are running very well at 5 GHz already. This is absolutely insane. Many of these Ivy Bridge CPUs, they maxed out at around like 4.5 GHz, 4.6, 4.7. Some couldn't go much over like even 4.3 or 4.4. But yeah, so let's open the AI Suite overclocking tool, because I don't have a working Turbo V core for this particular motherboard right now. So we can alter the volts a little bit. Let's drop it down to 1.27. So it dropped. So now it's 1.27 and it should drop down to 1.26. I just want to see the lowest voltage for 5 GHz. 1.26, 1.264, somewhere around that mark. Still running. Average of the core maximums, and it failed. Okay, so 1.26, something like that, the lowest voltage for 5 GHz. Okay, so now it actually passed on second attempt. So 5 GHz, 1.27 or 1.26 volts when measured under load. So very, very good score overall. So let's try to aim for 5.1. So let's close this one. And we can actually follow the temperatures by keeping the core temp open, like to see do they actually ramp up when we raise voltage and the clocks. So let's increase this to 1.325 for example. Apply and yes. And ratio group tuning 5.1. So now it's at 5.1. Doesn't really change that much. 42, 49, 47, 48. Max temp 50 on the second core. So 5.1, 1.325 volts. So we went up by like 50 millivolts on the voltage, and we rose the clocks by 100 megahertz on all of the 4 cores. And we failed, but I think if we try again, it should pass. But I think this is the lowest voltage for 5.1. So 944 passed. Let's save this one. So 5.1 has passed, and I think we can call this the lowest voltage for 5.1. No need to lower it even more. I don't think there's much headroom left because we failed once already. So 5.1. Let's keep going. Maybe try 1.365 and 5.2. So 1.365 volts, 5.2 gigahertz. And remember, ultra high load line calibration, there's roughly 10 millivolt drop under load. When I tested this before, 1.365 set. If I used extreme low line calibration setting, I mean 1.365 set was 1.391 under load, and ultra high like around 10 millivolts lower than the set value. So let's try this. 1.365 for 5.2. $46.50. Okay. Try one more time. If it fails, let's increase the voltage a little bit. Okay. So 1.375. So this should be around 1.365 measured under load. So the lowest voltage for 5.2 GHz Cinebench is something like 1.365, 1.375. Currently 1.375 with ultra high low light calibration setting. So 10 millivolt drop under load, at least on water cooling. On LN2 it might drop or droop even more. So on LN2 should definitely use the extreme option. So in that regard, the load line calibration settings on these older Maximus series boards isn't that good. You want the most accurate value under load, what you set in the BIOS. So 5.2. Actually, let's double check before we increase the clocks even more. Let's just look at the VCore value. 1.384, 1.376. But this isn't as accurate as a multimeter, and I have checked it already. So let's increase even more. So let's open AI Suite once again, Tool, Turbo V Evo, and let's set something like 1.435, 5.3. So 5.3 gigahertz across all of the 4 cores. But now it will definitely start to get harder. Just look at the temperatures again. Nope. Try one more time, and then if no, then we will increase the vehicle a little bit more. But at this level, I think the extreme option would be better, because then you would get at least the value you set under load, I mean. So let's increase to 1.445. $52, $59, $56, $55. So we are still under 60 degrees, and we blue screened. So let's try again. I think this should be able to pass.
You gotta save me now. I'm slipping so far down. It's only you I trust to set me free from this. I don't know how I got into this awful spot. I don't know where it ends. So I could use your helping hand tonight.
So 5.3 gigahertz passed. Now I actually changed the load line calibration setting from ultra high to extreme. The VCore I manually set was 1.425, and with extreme load line calibration it overshoots up to like 1.44, 1.45. So I can confirm you that. So Tool, Turbo V Evo, 1.425. And we can quickly, before we set any higher clock and voltage, we can actually check on CPU-Z that how the VCore actually moves. So look at the VCore or core voltage value. So 1.44, 1.448. Run. 1.45, 1.44, something like that. So we can still try one notch higher. So 5.4 gigahertz in Cinebench R15 on an Ivy Bridge CPU. Sounds pretty wicked if you ask me. So Tool, Turbo V Evo. Let's try. Well, we have to increase this like up to 1.485. So this will be a bit over 1.5 volts under load, but for testing purposes it should be just fine, because the average of the core maximums didn't really go above 60, even at this voltage. So temperature wise we are still very, very good. So let's group tuning and 5.4. So 5.4, but I think this will crash because this is very hard figure to achieve already. But yeah. Okay. At this point, the limiting factor starts to be the temperature, not really the voltage, because when we go, or if you go this high on the VCore on water cooling, it really doesn't scale that well anymore. So 1.5 volts is very high value on water cooling. So one more attempt. I think 11.5 should pass. So let's try R15 one more time, but I think it will fail. Yep. Let's try 11.5. This was actually a bit more popular Cinebench back in those days, even during Ivy Bridge days. R15 was still relatively new. Okay, let's increase the VCore a little bit more. So 1.5. But yeah, temperature is not really an issue, but if it doesn't scale, if it stops scaling on the voltage, there's no point to increase it even more. 62, 66, 66, 64. Almost. It's close. So 11.5 passed. Very good score. R15 is a little bit harder, and the same thing goes for R20. R20 does use some, like, it does use AVX a little bit. That's why it's definitely harder than R11.5 or R15. But even R11.5 at 5.4 is damn amazing figure on just on water cooling. 5.5, I don't think there's even a point to try, because that's definitely hard. So, capture that and try our R15 one more time. So the maximum, the average of the core maximums stayed at around like 66, 67 during last run. But I think this will fail. Yep. So let's try. Let's close core temp. Let's set this at real time. Close that. Nope. Okay, so with VCore value of 1.505 set, I mean with extreme load line calibration, it actually now passed when we didn't follow the temperature and when I ran the test in real time. When you run the test like Cinebench in real time, it's a tiny bit easier to pass. So when you do like extreme overclocking, you should always use real time for the final push. So 1011 points in R15 at 5.4 gigahertz, and I also increased the memories up to 2666 with same timings. The Benchmate reports temperatures as 27 minimum, 64 maximum. But we already saw the temperatures in the previous attempt, so like 66, 67 for the average of the core maximums. So 5.4 gigahertz on water cooling with an Ivy Bridge 3770K. That is absolutely insane. So let's try. Let's actually try. So I will set it to normal. Set it to normal and core temp. Disable that. Yeah, 61, 68, 66, like 66. So that we just to see the temperatures. So around like 65, 66. So the Benchmade temperature measurement is actually quite accurate, even when the test is running in real time and the whole system hangs during the test. Yeah. So just to confirm you. So these were the voltages for 5.4 GHz Cinebench run, 1.505 set value on the VCore with extreme load line calibration. So like 1.52 under load, something like that, 1.52, 1.53, somewhere in between. So absolutely insane. If you go on hwbot.org, for example, the highest water cooling result on a 3770K has been like 5.3, 5.4, but you can never know what are the real like temperatures under load, because many people are running chillers, but they still state the cooling as standard water cooling, like ambient limited water cooling. So this is for sure up there among the best in the world. So will be very interesting to see the CPU later on LN2 when I get the chance. I would expect, if it scales correctly, like 6.6 to 6.7 gigahertz in W prime, Cinebench and so on, because we already saw how good the KPX thermal paste performs between the die and the IHS. I really want to try this for one more time. So okay, no. Let's try 11.5 and okay, so I think that's pretty much it. I tried the 2800 MHz memory multiplier with those Samsung D-Die G-Skill Trident X memory sticks, but it doesn't want to post. I think it needs the CPU to be put on LN2. Cold on the IMC should help with the maximum memory frequency the CPU can reach. So was worth it to try it anyway. So 2666 is the highest like solid memory multiplier with the CPU on just ambient cooling. Now for a brief moment I actually swapped those Trident X memories onto G-Skill Pi power chip semiconductor based DDR3 memories. So these are 2 times 2 GB sticks, but look at this, 2400 MHz, but 7, 11, 7, 28 command rate 1 timings. This is done with memory voltage of 1.7 and 1.25 on the system agent and I/O, and it does seem to work just fine. I ran Cinebench R15 at 5 GHz again, and the score was higher this time than before. So 938 points versus 920 something. I think it was 924. So yeah, so looks very, very good. So I actually looked at those top water cooling results made with the 3770K CPU on Hardware Bot. And if you look at the top scores made by Punk, Sots and some other guy at like 5.4 to 5.45 GHz or 5.5 GHz in Cinebench R11.5 and R15, those are actually made on a water chiller. So you can see like huge insulation foams around the water cooling tubing. So that's not like real ambient water cooling setup. So based on these results, we saw today like 5.4 GHz solid in R11.5. I passed 5.4 GHz in R15 twice. Once before making this entire video and once during this video. So the score before this video was 1008 points, and now I got 1011 points during this video. W prime should be easier than any of the Cinebenches, so I think I could pass that at 5.4, even under 1.5 volts, but of course I didn't test that, so I cannot guarantee. And we actually saw 5.7 GHz for a brief moment with just one core enabled. 5.7 on an Ivy Bridge CPU that's not soldered and only at 1.5 volts. That is absolutely insane figure. Because remember, many people were only struggling at around like 4.3, 4.4, 4.5, of course with lower voltage than 1.5. But if they could validate, let's say 4.7 with one core, I'm at 5.7. That's a huge difference. So I'm extremely happy with this CPU. But of course the cold test will determine everything. So if it doesn't scale with temperatures, then it's not going to be the rank 1 CPU. So there are still some variables that can come into play. But if it scales like my old CPU, and based on these water cooling results, this CPU should be able to do like 6.6 to 6.7 GHz in Cinebench, W prime on LN2, and single core, who knows. I would assume at least 7 GHz, but that has to be tested separately. But let me know what you think. Did you like to see these overclocking tests, like step by step, like the lowest VCore requirement for a given clock speed, like what's the voltage requirement for 5 GHz, 5.1, 5.2, 5.3, 5.4? Because now you can use these values to compare. Like if you are trying to bin these CPUs yourself, these are your new target values to aim for. Of course, this is extremely hard target, but the CPU temperature will determine a lot. At least it feels so that this CPU is very picky on the temperature. So the 5.4 GHz run at 1.505, something like that, the average of the core maximums during that run was like 67 or so. If the temperature was over 70, it would have crashed. So remember that. If I could get the temperatures even lower, then maybe the VCore requirement could come down like under 1.5 volts. So if I purchased the direct die frame, I could maybe squeeze 5 degrees, maybe 5. I would assume that it's not possible to gain more than 5 degrees at this level, but who knows. It could be worthwhile testing, but yeah. So definitely like this video if you liked it, and subscribe to my channel, and please leave a comment down below if you have some comment about this testing, or what do you think about this particular CPU and motherboard. The Maximus 5 Extreme is very, very good For memory overclocking, it seems quite solid. The only minus is maybe the load line calibration. It's not very accurate. So when it comes to load line calibration, we want a static value. We want to see the same value we dialed in the BIOS under load when measured with a multimeter. Now with the second highest option, we are getting 10 millivolt droop, and with the highest setting, we are getting like 20 to 30 millivolt overshoot. So when I checked it myself, 1.365 volts with extreme load line calibration, that was 1.391 under load measured with a multimeter. So that's like 26 millivolt overshoot. And even in idle, it was like 12 millivolt overshoot. So just saying. So the load line calibration is not like perfect. It's not something we have on the modern EVGA motherboards like Z390 Dark, Z490 Dark. Those motherboards have very solid load line calibration options. Also, the BIOS seems to corrupt sometimes. So when I fail some settings, or if I do a reboot, many of the settings are changed to weird values, and I have to reload a profile to get them to correct values once again. So I'm not fully sure what's that. Is it some bug in the BIOS itself, or is the battery dying or something? But I'm not fully sure. I need to ask around about that. But overall, the Maximus 5 Extreme seems very, very solid. I really liked the Z77 OC formula, but if it has some random def issues, that's not a very good thing either. So yeah, but anyways, I hope you like to see this video, and I hope you will come back to my videos once again in the future. So thanks for watching once again, and I will see you on the next one.